Hey guys, we're on 6-10 Solve Systems of Equations by Graphing on page 174 in the purple book. The one objective here is we're going to solve a system of linear equations simply by graphing. Okay, I do want you to copy down this concept map into your notebook or onto a larger index card. It's something that will really help you, kind of breaks down what all is involved or what all branches off of linear equations. We have the slope-intercept form, we have slope, we have standard form, we have point slope form, we have our slope, our y-intercept, and all those things. So this is a really important concept map for you to be able to fill in or understand within the next week or so, okay? Okay. A system of linear equations is a set of two or more linear equations, which we have right here, with the same variables, okay? So right here we have y equals x minus 1, and then y equals 3 minus x, right? A solution of a system of equations in x and y is an ordered pair of x and y. That is a solution of each equation in the system. So first we have to make a function table for each equation. Then we have to graph each of the equations on a graph or coordinate plane. The point where the two lines intersect is the solution of the systems. Okay? So here we have y equals x minus 0, or sorry, x minus 1, and then y equals 3 minus x. So the first thing we're going to do here is we're going to assign a value such as 0 to one of the variables and solve for the other. So if I want to figure out what my x is here, I'm going to make y 0. So for this one over here, put 0 equals x minus 1. So I just add 1 to both sides, add 1 to both sides. X equals 1. So when y equals 0, x equals 1. So let's do that. I'm going to put that kind of somewhere down here. So we're going to have both. Oops, see. So when y equals 0, x equals 1. Alrighty? Let's say that y equals a negative 2. If y equals a negative 2, we sub that in for y. X minus 1. Add 1 to both sides. We have negative 1 equals x. So when y equals negative 2, x equals a negative 1. Okay? All right, let's say that x equals 0. I'm going to erase this a little bit, give us a little bit of room. Okay? If x equals 0, we have y equals 0 minus 1, which is negative 1. So when x equals 0, y equals negative 1. Okay? I'm going to fill in the last one. If x equals 4, so y equals 4 minus 3. Oh, that's the problem. I think I'm messing this up. It's 4 minus 1. Duh. So if x equals 4, I sub that in for the x spot. So y equals 4 minus 1, which is going to be y equals 3. Let's put that right there. Okay? That's all you're doing. I mean, I always start with maybe like negative, maybe a negative number. But if you're more comfortable starting with 0, start from 0 and kind of go from up there. So I'm going to kind of fill in this one over here. So this one, if x equals negative 4, my y is going to equal 7. If x equals negative 2, my y is going to equal 5. If x equals 0, my y is going to equal 3. If x equals 2, my y is going to be a positive 1. Okay? That's all you're doing there. It doesn't have to be any particular number. 0 is an easy one to start from, and then kind of go up from there. If you start from a number that's closer to 0, like negative 1 or negative 2, and then go to 0 and then go to positive numbers, it's a little bit easier, but it's totally up to you. All right, let's graph. So that first coordinate point man was for y equals x minus 1. That first coordinate point, if you look back at your function table, was negative 4, negative 5. So we're going to go 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, this is our first coordinate point. Pardon my little dots. Okay. My next one was negative 2, negative 3. 1, 2, 3. The next one was 0. Oopsie. Did we go right? Oh, come on. There we go. -2, -3. Okay. My next one was 0, -1. Oh my gosh, I cannot draw to save my life. Okay. Then we had 2, 1. Then we had 4, 3. Alrighty, so this line is going to kind of look like this. I know this isn't going to be exactly right because I can't use a ruler on this bad boy. So that's my first line. Then I graph my second function. So look at that second function table for y equals 3 minus x. Okay, my first point was -4, 7. So I go on my x-axis. I'm going to use a purple for this one. So -4, 1, 2, 3, 4, +7, 1, 2, 3, 4, 5, 6, 7. Alrighty. We had -2, +5. Right there. We have 0, 3. We have 2, +1. Interesting. Then we have 4, -1. So then I draw my straight line through all the points. Oopsie. Oh my god, that didn't even hit where I wanted to hit. Oopsie. Okay. Pardon my terrible drawing. Okay. So I know I can't really tell because my drawing is so terrible, but if I drew it straight, it should have hit. Look at the orange line instead, if I can draw the orange line. Oh my gosh, it's not going to work today. Okay, let's draw the orange line. Okay, it hits right here at 2, 1, I believe. So 2, 1 is my solution for this problem. Okay, so if x equals 2 and y equals 1, alrighty, you need to substitute x equals 2 and y equals 1 into each of the equations in the system. Okay, once you do that, you'll see that it's true. So we would do y equals x minus 1. Okay, so we do 1 equals 2 minus 1. It should be 1 equals 1. So that would make a true statement. So that is your solution to the problem. Okay, all you do, even if you're given, so like in the workbook, it'll give you all the x values, so you substitute those into the equation, and you solve for y. If they don't give you anything, then you pick the numbers that you want to plug in there for x or for y, and then you solve for it. Okay? Okay. If the graph consists of a system of linear equations with two parallel lines, then the system has no solution, or a circle with the line through it. Okay? If it consists of coincident lines or the same line, then the system has infinitely many solutions. Okay? You're going to see that at the top of 175. Okay? So I want you to do this problem right here. We'll do 4x plus 2y equals -8. Then we're going to do 2x plus y equals 2. Okay? So I'm going to say that y equals 0 first in this problem. So if y equals 0, then it's going to be 4x plus 2 times 0 in place of y equals -8. That's going to cancel out and be 0, so we have 4x equals 8. We divide by 4, x equals 2. Okay, same thing over here. If y equals 0, then we have 2x plus 0 equals 2. The 0 cancels out. We divide by 2, and x equals 1. Okay? So that's all you do for these problems. These two lines will be two parallel lines. And you'll see that so there's no solution. The problem below that where it says use a graph to solve the system of equations at the right, where it says y plus 2x equals 2. Then it has 3y plus 6x equals 6. Those two equations are the same, so they will be on the same line, so they have an infinite amount of solutions. Okay? What you are going to do for the rest of this video is do numbers 1 and 2 of the try these. Okay, so you're going to have to draw your own graphs for this. If I were you, I'd print them out online. That'll be a lot easier to graph. and then we will do the rest of that in class. Okay? Good luck, and don't forget to do your packet. Bye, guys.